Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. So in a previous session students, we had started with the chapter number 3 from class 11th called as Trigonometric Functions. What we did in the previous class was we had just a very brief introduction to trigonometry, and we also saw different system of measurements of measuring an angle, correct? So what are the three systems of measurement? Sexagesimal system of measurement, where we measure the angles in terms of degrees. Centesimal system of measurement, where we measure the angles in terms of grades. Whereas the last one is circular or radian system of measurement, where we measure the angles in terms of radians. So these are the three systems of measurements used to measure an angle. Okay, we also came across the relationship between degrees, grades and radians. Okay, so that is d by 90 is equal to g by 100 is equal to 2r by pi radians. And we also solved one question from different types of different systems of measuring an angle, where the angle between the hour and the minute hand of the clock is measured. So in this class what we'll be doing is moving on to the next topic. So in this class we'll be seeing the very first topic called as ASTC rule. Okay, so this rule was introduced in class 10th as well, but in class 10th we have discussed only the first quadrant. Okay, so here we'll be discussing all the four quadrants. Now students, this is a very important rule. I'll tell you what is the use of this rule as well. So before we start with the use of this rule, now students, tell me this. In the trigonometric table, the table is only consisting of 0 degrees, 30 degrees, 45 degrees, 60 degrees, as well as 90 degrees. So if I ask you any ratio, for example, what is sine 45? Okay, by referring to this table, you can tell the answer, correct? Similarly, what is tan 45, cot 45, secant 45, cosecant 45? Okay, with the help of this table, you can easily tell the answer because the value of 45 is here. So you can tell the answer by referring to the table. If suppose I ask you what is the value of sine 150 degrees, what is this value? What is sine 150 degrees? So if I ask you, the table is only ending at 90 degrees, right? So there is no 100, 120, 130, 140. We don't know the values. But the question is asked like this: what is the value of sine 150 degrees? So what you have to do is, okay, in this case, you have to use ASTC rule and you can tell the answer for sine 150 degrees. So what is this ASTC rule? We'll come to know that. So students, before we start with ASTC rule, the basic things, okay, we'll change the color first of all. We'll draw y-axis, correct, vertical line, y-axis, and a horizontal line, x-axis. So this is x, this is y dash, and this is x dash. Intersection of both the axes, this point is called as what? This point is called as the origin. What is the coordinate of that point? 0, 0. Now students, ASTC, right? First we'll write those letters. This is A, S, T, and C. ASTC. Apart from this, what we'll write next is, okay, we will write the angles. So what angle is this, students? 0 degrees, correct? 0 degrees. This will be 90 degrees. This will be 180 degrees. This will be 270 degrees. And this again, one complete circle, see, in anti-clockwise direction, one complete circle. So this will again be 360 degrees. I hope you're understanding this. I'm going very slow, students. Okay. ASTC 0, 90, 180, 270, 360. Apart from this, what else we can write is the quadrant names. So this is called as the first quadrant. First Q I have written, first quadrant. Second Q, second quadrant. Third quadrant. And fourth quadrant. Okay, now here comes the important part. So students, this is what basic very basic, everything you know here, 0, 90, 180, 270, 360. ASTC, remember that, okay, in anti-clockwise direction only. First quadrant, second quadrant, third quadrant, fourth quadrant. So this is our outline, okay, we have created the outline. Now we are getting into the ASTC rule, alright. So please concentrate, very important rule this is. So now students tell me, if there is a line here, exactly on the Y, if I draw a red line, what is its measure of angle with respect to the horizontal? Yes, that is correct. 90 degrees would be the measure of this red line with respect to this horizontal x-axis. Now if suppose I draw the red line here, like this, what would be the angle of this red line with respect to the x-axis, anti-clockwise direction, students, like this? Okay, what would be the measure of this red line with respect to the x-axis? Okay, so somewhere around some 70 degrees. Okay, but roughly we are telling, right? We don't know, we have not measured it yet. But can we tell that here this angle will definitely be lesser than 90 degrees? Correct, students? See, this red line on y-axis is exactly how much? 90 degrees. If you come little bit on this side, like this would be lesser than 90, correct? And going back, if you go forward like this, it would be greater than 90. This is exactly 90, so it's like this, students. Okay, so we'll keep this here like this. So this is pointing at 0 degrees, right? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130 until 180. Again moving further, 190, 200, 210, 220 until 270. And again 280, 290, 300, finally reaching 360 degrees. Okay, which means in the first quadrant, what will be the angle? In our first quadrant, the angle will be between 0 degrees to 90 degrees, not greater than 90 degrees, students. Understanding? So how do we represent that in terms of numbers? We'll write 90 minus theta. This is 90, right? This is lesser than 90, so 90 minus theta. This will be greater than 90. So what we'll write here? 90 plus theta. Understanding? Lesser than 90. So what is this theta? Theta might be even 1 also. So 90 minus 1 is how much? 89. So 89 is here. 90 plus 1, 91 is coming in the second quadrant. Understanding? So next we are taking 180 as reference. You go above, it will be 180 minus theta. You go below, students, it will be 180 plus theta. Taking 270 as reference, okay, like this. Go that side, it will be lesser than 270, right? So that will be 270 minus theta. Come on this side. After 270, it is 271, 272, 273, correct? So this will be 270 plus theta. Take this 360. So below 360 will be 360 minus theta. Above 360 will be 360 plus theta. Understanding how are we writing these numbers? 90 to the right, 90 minus theta. Okay, sorry, to the left it is. Okay, to the left it is 90 minus theta, to the right it is 90 plus theta. Same thing. Above 180 minus theta, below 180 plus theta. Again 270. That side 270 minus theta, this side 270 plus theta. Same for 360 as well. But there is one special inclusion in fourth quadrant. That is nothing but minus theta. So this completes our ASTC rule, students. So whatever you can see in this border, okay, this complete border is ASTC rule. So you have to memorize this. Okay, remember this. Apart from this, what else is important is, on the right hand side I'll be writing. So here you can see, if suppose you get 90 and 270 and 180 and 360. So here we'll write C and here we'll write EMC. Point number 1, point number 2. Make a note of those both points. I'll tell you what are those. So this complete red box plus those 2 points. This is what you have to remember. This together comprises of the complete ASTC rule. Now where do we use this ASTC rule? I said you right, to calculate this kind of angles. Okay, we'll be using ASTC rule. Okay, students. So now let us find out by using ASTC rule. Okay, there are some more things to be explained. What does A stand for here? A stands for all. A stands for all are positive. All are positive. What are all? I'll tell you that. What does S stands for here? S stands for sine and its inverse are positive, others negative. T stands for tan and its inverse are positive, others are negative. And finally C stands for cos and its inverse are positive, others are negative. So that is what these letters are representing. So you can remember it like this: all sine T cups. All sine T cups. That is nothing but ASTC rule. A stands for what? All are positive. S stands for sine and its inverse are positive, others are negative. T stands for tan and its inverse are positive, others are negative. And finally C stands for cos and its inverse are positive, others are negative. Why only this is positive? Why others are negative? Okay, we can do that. We can prove that as well. So we'll do that as well. Apart from this, yeah, and these both points are also very important. So I'll tell you why these are positive. Okay, why others are negative? I'll come to that point again, students. So before we come to that point, we'll quickly solve this one small problem here. Okay, what is the value of sine 150 degrees? So that we'll do it on the left side here. So sine 150 degrees we have. And when you see the table is ending at 90 degrees. Okay, there is no 150 degrees in the table. So what you have to do is, you have to express 150 with respect to ASTC rule as well as table. So now you see, you do not know what is 150 degrees, but you know the table, correct? And you also know the ASTC rule. With respect to whatever you know, that is the table and ASTC rule, okay, expand 150 in such a way that you will be getting the value of that. So how can we express sine 150? Again, this can be expressed in two different ways. The first way is sine of 90 plus 60. Why only 90 plus 60? Why not 100 plus 50? Students, understand. I said you know only two things, right? You know ASTC rule and you know the table. In the table, we do not have 50 degrees, point to be noted, correct? But we have 60 degrees in the table. And why 90 here? Because here also we have 90 degrees. See, it is defined with respect to 90 minus theta, 90 plus theta, right? So you can also express this as sine 125 plus 25, correct? But 25 degrees we don't know. So whatever you know, keeping that, you can derive the others. I hope you're understanding this. Okay, so we are expressing 150 as what? Sine of 90 plus 60. Another way of expressing this is sine of 180 minus 30. Why 180 minus 30 only? Why not 200 minus 50? Because 200 is not defined here. See, 200 is not defined. What are defined? 0, 90, 180, 270, 360 are defined. 180 is defined, right? So that is why we are taking 180 here. Understanding? Whatever is in this ASTC rule and the table, only with the help of those two things, we are expanding this 150. Understood? So now, let us solve this first. 90 plus 60. This is very similar to what? 90 plus theta. What is theta, students? What is theta? 60 degrees is theta. 90 is as it is. Now, whenever you see 90 plus theta, what you have to think is 90 plus theta is coming in which quadrant? You see the table and tell 90 plus theta is coming in which quadrant? 90 plus theta is coming in the second quadrant. And what is in second quadrant, students? Which letter do we have in second quadrant? S, which means what? Sine and its inverse are positive, right? Others are negative. Now what do we have here? Sine. So the very first thing what you have to do is write plus. Why are we writing plus here? Because 90 plus theta is lying in the second quadrant, and in second quadrant sine is positive. That is the reason we are writing plus here. Okay. Next. So 90's work is done. Okay. So 90 plus theta's work is done. It is only telling us in which quadrant it is and whether it should be plus or minus. So it is in the second quadrant and it is plus. Now the next thing what we are coming to do is, we have a 90 here. See this first point, 90 and 270 I have written C, which means change. Okay, what should we change here? We have to change the ratio. So what do we have here? Sine we have, right? It will become what, students? It will become cosine. Okay, if you have tan, it will become co-tan. If you have secant, it will become co-secant. Now we have what? Sine. So it will become what? Cosine, which is nothing but cos. Cos. So this work is done. 90's work is done. What else is remaining now? 60 is remaining. Right, 60. So now do you know what is the value of cos 60? Yes or no? Yes, it is in the table. What is cos 60, students? 1 by 2. So therefore, what is the value of sine 150 degrees? The value of sine 150 degrees is 1 by 2. How did we arrive at this value? We arrived at this value with the help of ASTC rule. Understood? So this is giving us 1 by 2, right? Okay, we'll also check out this. We must be getting the same answer. Alright. So what is the very first thing? 180 minus theta. Previously it was 90 plus theta, right? It was in the second quadrant. Now 180 minus theta is lying in which quadrant? See that 180 minus theta is lying in which quadrant? Second quadrant. And what is happening in second quadrant? Sine and its inverse are positive, right? So 180 minus theta means what should we do first? Here we have sine, so we will write plus. So 180 minus theta's work is done. Next, what do we have? We have the number 180. Correct? 180. See the second point here. 180 means what, students? No change. No change in the ratio. Let the ratio be as it is. So sine will remain as sine only. So this work is done. What else is remaining now? 30 degrees is remaining. So what is sine 30 degrees? Sine 30 degrees is nothing but 1 by 2. Understanding? So with the help of ASTC rule, we can derive or we can know the values of such type of angles. But always remember, when you have to express 150 or any other given angle, you must always try to express it with respect to ASTC rule as well as the table. Understanding? I hope you're understanding this. So any doubts here, students, you can just let me know. Now we'll come back to this point. Why all the ratios are positive here? So let us draw the right angle triangle like this. This is the right angle triangle. This is theta. Okay. So now this is what, students? Origin, right? 0, 0. So from here if you start, you're going to the right, which means what? It is positive. Again you're going up, which means what? It is positive. So obviously this line also will be positive. This is positive. This is also positive. So this also will be positive. So now define any ratios. You take sine, opposite by hypotenuse. Positive, positive. So therefore sine is positive. Take cos, base by hypotenuse, both are positive. So the ratio will be positive. Correct? Next take tan, opposite by adjacent. Both are positive. So tan also is positive. Similarly, cot will be positive, secant will be positive, cosecant will also be positive. In which quadrant? In the very first quadrant. Why? Because when we draw the right angle triangle like this is becoming positive and this is becoming positive. Now see this, students. See on this side, we'll change the color. Okay, so we'll draw the triangle like this. What is this, students? Origin 0, 0, but we are going to the left of origin. Correct? We are going to the left of origin. From origin we are going to the left side. So left side means what, students? It will be negative. So if this is 0, this will be -1, -2, -3 and so on. Correct? But you see the opposite, we are going up, +1, +2, +3, +4, like that. Understanding? And this line is also going up, right? It is not going down. It's not going below the origin. It's going above only. So this also will be positive. So see, only sine and cosecant are positive here. Sine is what? Opposite by hypotenuse. This is positive. The opposite side is also positive. So therefore sine is positive. Cosecant, hypotenuse by opposite, that is also positive. Others, now you see this cos, okay, adjacent by hypotenuse. Adjacent is negative, hypotenuse is positive, but positive by negative will give us how much? Negative. Are you understanding? So this is not that much important. Why this is positive, why this is negative, just an explanation, that's all. No need to remember this, okay, the explanation part. The same thing, whatever I have done here is applicable in third quadrant as well as in fourth quadrant. So why they are positive and negative, that is not important, students. You have to remember the ASTC rule, the numbers within it, okay, and how to express the given angles in terms of ASTC as well as the table. Understood? So this is all about the ASTC rule. So to find out the angles, values of such type of angles, we'll be using ASTC. Okay, moving on to the next slide. What we'll be seeing here is, first one, y is equal to sine x. Now we are going to discuss what is the domain and what is the range of the respective trigonometric functions. Now y is equal to sine x. What is its domain and range? How do we know that? Okay, we'll take the help of the graph. What is the function here, students? The function here is y is equal to sine x. So this is our function. So this is sine x graph. Okay, to be very clear with this, okay, we'll go to the next one, same thing. But here you can see the points. In the previous one, okay, there are no points. So it is not very clear to explain you. So in this slide you see, so this is what, students? It's written here, 0, 0. I hope you can see that. Okay. See, when a sign becoming 1, so students, it is always in the form of x, y, right? X is the first reading or the value, y is the second. What is the value of x? X is pi by 2. At x is equal to pi by 2, what is y? Y is equal to 1. Now check this. Y is equal to sine 90 degrees. Have a look at the table. What is the answer? The answer is 1. At x is equal to pi by 2, sine is 1. At x is equal to pi, which is nothing but 180 degrees, what is y? Y is 0. At x is equal to 3 pi by 2, what is y? Y is minus 1. At x is equal to 2 pi, what is y? Y is 0. So the sine graph is going on like this on the right side as well as on the left side. So you can see those readings. So this reading is corresponding to this. This is this, okay, this. So x and y value, students. So this graph is going infinitely on that side and infinitely on this side. So what we'll be writing as domain now? Domain are nothing but what? Input values. Y is equal to sine x, right? Whatever values you are going to input here, okay, those are called as domain. How long is it going? It is going infinitely on that side, x values. Here also it's going on infinitely on x values, right? So what will be our domain? Domain is nothing but x belongs to R, which is nothing but set of real numbers. Understand? Now what will be our range, students? Range. Range means the value of y. This is range. Okay, the value of y. Is y going above 1? See the graph. Is y going above 1? Here it is 1. Here it is 1. Here also it is 1. Okay, this side also it is 1. This side also it is 1. Exactly 1. It is not going 1.01 or 1.1. Exactly at 1 it is stopping. So the range will be defined as what? 1, comma. See the below one, students. Minus 1, minus 1, minus 1, minus 1, minus 1. In the below or below the origin also, it is going only until minus 1. It is not going below minus 1, right? So minus 1 with the closed bracket. Why closed bracket? Because below minus 1 it is not going at all. So closed bracket means including minus 1, not greater than minus 1. Okay, and here also not greater than 1 again. Understanding? So this will be our range and this will be our domain. How did we get the domain? All the x values, right? On that infinite, on this side also infinite. So x belongs to a set of real numbers. That's how we got our domain. And how did we get the range? By looking at the graph. So this is plus 1, this is minus 1. So always sign whatever value you input. Let us input 5000 here. In the place of x, you input 5000. Okay. Y will be in between plus 1 and minus 1. It will not go above plus 1. It will not go below minus 1. Understanding, students? So this is about the sign. So this is our domain and range for sine. Moving on to the next one. Y is equal to cos x. So this is our cos x graph. Okay. We'll go to the next slide. It's more clear here. At 0, 0, cos is not 0. See how much is cos? Cos is 1. See the previous slide. At 0, 0, sine is how much? Sine is 0. So that is why what is sine 0? Sine 0 is equal to 0. Check the table. Okay, sine 0 will be equal to 0. But for cos 0 is equal to how much, students? Check the table again. Cos 0 will be equal to 1. Okay, so at 0 it is 1. At pi by 2 it is becoming 0. Cos is becoming 0 at these points. See, at this point, at this point, at this point. Okay, at this point, at this point, at this point. Pi by 2, 3 pi by 2, 5 pi by 2, continuation. 7 pi by 2, 9 pi by 2 means at odd 9, at odd pi by 2's, cos is becoming 0. Correct? 1 pi by 2, 3 pi by 2, 5 pi by 2, next would be 7 pi by 2, next would be 9 pi by 2, next 11 pi by 2. At all these values, what is happening? Cos is becoming 0. Where is cos becoming 1? At 0. So this is at pi, that is at 180 degrees, it is becoming 1. Again you see here, at 3 pi, it is becoming 1. Understanding, students? So this is about the cos. So what would be the range of cos? What are the values of x? Again, see x axis, see the values. So even this is a value of cos, even this is a value of cos. So the domain for cos is x belongs to the set of real numbers. What would be the range of cos, students? Range, you see this, plus 1, plus 1, plus 1, minus 1, minus 1, minus 1. Not going above plus 1, not going below minus 1. Therefore, range will be equal to how much? Plus 1 to minus 1. Very simple, students. What is the meaning of domain? X values. See the graph and tell what is the x values? Real numbers written. What is range? Y values. See 1, minus 1, minus 1, 1, minus 1, 1, minus 1, 1. So range is 1, comma, minus 1. As simple as that. Okay, do not confuse it. It's very easy actually. Okay, so this is second trigonometric function. Moving on to the third trigonometric function, y is equal to tan x. So this is our tan x graph. So this is going infinitely up. Okay, and this is going infinitely down. Understanding? So we'll go to the next slide again. Here we have the values. So see this. Okay, that value is not present. Here we'll see. At x is equal to minus 2 pi, what is y? 0. At x is equal to, okay, so this is for this point. Okay, at x is equal to minus pi, what is y? 0. 0, comma 0 for this one. Okay, pi, comma 0, 2 pi, comma 0, 3 pi, comma 0. So what is x again? All real numbers, right? What is x again? Before we define x, what is tan x? We'll see, students. How is tan x defined? Tan x is defined as sin x by cos x. Is this correct? Where cos x should not be equal to 0. If it is equal to 0, then it is called as what? An indeterminate form. Okay, class 11 limits, indeterminate forms. Okay, so that is not yet done, I think. Okay, so cos x should not be equal to 0. In that way, we have to choose the domain or the values of x. Now we'll go to the previous slide again. Where is cos x becoming 0? See, cos x is becoming 0 here. Cos x is becoming 0 here. Cos x is becoming 0 here. On this side, you see, minus pi by 2, minus 3 pi by 2, minus 5 pi by 2. So minus is missing there. Okay, minus 5 pi by 2. So basically, at what values cos x is becoming 0, students? Odd pi by 2 values, cos x is becoming 0, right? So here for the domain of x, what can we write as? X belongs to all the set of real numbers except 2n plus 1 pi by 2. This will be the domain for tan. Understand what I have written here. 2n plus 1 pi by 2. Now you substitute n is equal to 0. If you substitute n is equal to 0, 0 plus 1 is 1. 1 into pi by 2 is pi by 2. At pi by 2, what is happening? You see, at pi by 2, cos is becoming 0. Okay, now put n is equal to 1, students. Put n is equal to 1. 2 into 1 is 2. 2 plus 1, 3. 3 pi by 2, what is happening? See again. So here it is. At 3 pi by 2, what is happening? Cos is becoming 0. Understanding how we are writing the domain here. So x is belonging to all the real numbers except, so that is why we are writing minus there, 2n plus 1 of pi by 2. So except these values, other values you can put in the place of x. But if you put this value, what will happen? Cos x will become 0 and tan x will be undefined. Understanding? So this is our domain for tan x. What would be the range of tan x, students? Range of tan x. Why? How far is this going? Infinitely up. We don't know what is the last number there. So it is infinite. How down it is going? How down it is going? We don't know how down it is going. We don't know which number is down below. So it is going infinitely down. So the range would be minus infinity to plus infinity. So this is our range for tan x. See, previously what happened, students? The graph is stopping here. It is not going above continuously, right? It is stopping here. Here also, see, it is stopping. That is why the range was plus 1 to minus 1. Here what is happening, students? It is going indefinitely up. It's going indefinitely down. So we don't know which numbers. We are writing minus infinity to plus infinity. Why are we subtracting this? Because we don't need cos x to be 0. If cos x becomes 0, tan x will become undefined. That is the reason we have written domain like this. I hope you're understanding this. Okay. If any doubts you're getting or something is not clarified to the students who are watching this, please do comment in the comment section. Okay, I'll be clarifying that again. Moving on to the next graph. Y is equal to cot x. So again, we'll go to the next picture. So here you see at 0, no graphs are passing through it, correct? So at minus pi by 2, it is 0. At minus 3 pi by 2, it is 0. At minus 5 by 2, it is 0. Here also pi by 2, 0, 3 pi by 2, 0, 5 pi by 2, 0. And it goes on like that. Okay. So before we discuss about the domain and range, what is cot x? Cot x is nothing but cos x by sin x. And what is the condition, students? Sin x should not be equal to 0. Why sin x should not be equal to 0? If you put cos x by 0, what will be the answer? The answer will be undefined. So what you have to do is take your calculator, okay, write in that 1 divided by 0 and press equals to. Okay, and see what is the answer you are getting. Okay, the calculator will display error. Means we don't know what is the answer for anything which is divided by 0. So that is the reason what we are doing. We are not making it as 0, students. We are keeping it non-zero only. So now how do we define the domain of cot x? So we can write x belongs to R, set of all the real numbers, correct? Now sin x in the denominator, right? Okay, we'll go to sin x graph now. We'll see where is sin x becoming 0. Sin x is becoming 0 here. Sin x is becoming 0 here. Okay, it is becoming 0 here, 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 and here. Pi, 2 pi, 3 pi, 4 pi, next is 5 pi, minus pi, minus 2 pi, minus 3 pi, minus 4 pi. Sin x is becoming 0 where? Sin x is becoming 0 at n pi. N can be any number. Odd or even, it does not matter. Odd, you see, pi, 1 pi. Odd. Even, 2 pi. So how do we write the domain of cot x then? The domain of cot x can be written as x. Okay, here I have written. X belongs to all the set of real numbers except n pi. Except n pi, x belongs to all the set of real numbers. Because at n pi, what is happening? Sin x is becoming 0. If sin x becomes 0, what will happen? Cot x will be undefined. That is the reason the domain of x is all the real numbers except n pi. Okay, moving on to the next one. The domain y, same thing, minus infinity, sorry, plus infinity, minus infinity. So we'll write minus infinity to plus infinity. So this is the domain and range of cot x. Understand? Okay, moving on to the next one. Secant x. So how is secant x defined? 1 by cos x. Cos x is becoming 0 where? 2n plus 1 of pi by 2. At these intervals, what is happening? Cos x is becoming 0. Okay, so we'll see the labeled graph here. At x is equal to minus 3 pi, it is minus 1. Minus 2 pi, it is plus 1. minus pi minus 1, 0, 1, plus pi minus 1. Okay, this is just a graph, students. By looking at the graph, you have to write the domain and codomain. Sorry, domain and range. So what is secant x again? Secant x is nothing but 1 by cos x. Can cos x be 0? 1 by 0, what is the answer? Okay, check your calculator again if you have not yet checked it. Okay, the answer will be error. Okay, any calculator you can check. Even in your mobile you can check it. So 1 by 0 is error. So what we'll do? Here we will write cos x should not be equal to 0. Okay, so if cos x should not be equal to 0, then x is belonging to the set of real numbers except 2n plus 1 of pi by 2. So this will be our what, students? Domain. And what will be the range here? See the range. It is stopping at plus 1. Okay, so what is that below? So here it is plus 1, right? So see, this is 1. Is it coming to 0.5? Is it coming to 0.1? No, it is not coming. So we can write, it's not like that. 1 second. So here what we can write is, we can write open bracket. Why open bracket? We don't know which is the highest value here. It is going infinitely, right? Infinity to 1 square bracket or closed bracket union again square bracket. It is again starting from minus 1. Minus 1 comma infinity. So this will be our range for the graph y is equal to sin x. I hope you are very aware with this. Open bracket, closed bracket. What does they mean? Okay, so this I have explained it in the chapter of sets. Intervals, there is one topic. So there I have very clearly explained what is the meaning of open bracket and closed bracket. So if you do not know what is this, kindly refer the sets videos. Okay, the heading will be intervals. So there I have clearly explained what are the meanings of this. So this will be the range for y is equal to secant x. Understood? Okay, moving on to the next question. Y is equal to cosecant x. Again, this is the graph, students, whatever you are seeing on the screen. Okay, labeled one we'll see here. So this is the labeled one. And how is cosecant x defined? Cosecant x is defined as 1 by sin x. Can sin x become 0? No. Why? If sin x is 0, then cosecant x will be undefined. So here what will we write? Sin x is not equal to 0. So now, then what is domain? X belongs to a set of all real numbers except n pi. This will be our domain. And what will be our range? Y belongs to, okay, so again there is a mistake here, small one. Okay, not the closed bracket, it is open bracket. Open bracket infinity to plus 1 union minus 1 to infinity, again the open bracket. So this will be the domain and range of cosecant x. I hope you're understanding this, students. So we'll just summarize whatever we have seen. Okay, in the very last slide. So the very first thing what we saw in today's session was ASTC rule. All sign teacups. A is belonging to the first quadrant, S to the second, T to the third, and C to the fourth. In the first quadrant, all the trigonometric ratios are positive. In the second, sine and its inverse are positive, others are negative. In the third, tan and cot are positive and others are negative. And in the fourth one, cos and secant are positive and others are negative. Why do we use ASTC rule? To find out the angles or the values such as sine 150 degrees, which we have taken as example. Apart from this, so here we'll do, we'll wrap it up, students, very quickly. So we'll write ratios here. Sin x, cos x, tan x, cot x, secant x, cosecant x. Okay, domain r x minus n pi sine by cos. So it will be 2n plus 1 pi by 2. So this is r minus, I'm sorry. Okay, here it will be r minus n pi. Here it will be again r minus n pi sine by cos x, 1 by cos x. Here it will be r minus 2n plus 1 pi by 2. Cosecant is 1 by sine. Yeah. So 2n plus pi by 2. Here minus 1 to 1, same thing, minus 1 to 1. Range for tan x. So that is, we have written here. By looking at the graph, range minus infinity to plus infinity. Cot x is same thing, minus infinity to plus infinity. secant x secant x domain is this, okay, and the cosecant x domain is this as well. So you can just fill those in these gaps. So this will be the summary of today's class. We have seen what is ASTC rule as well as the domain and range of all the trigonometric functions. So I'll be seeing you in the next session very soon, students, with the next topic of trigonometry. Until then, share, like and subscribe Vista's Learning. Thank you.